Swayam Prabha. Digital India. Educated India.
First up.
Good evening, students. This is the first live interactive session for the NPTEL course, Urban Land Use and Transportation Planning. We haven't received that many questions yet, but maybe there was some issue with the scheduling. It was done a little bit faster. But in any case, we have gathered the questions which were available to us during the last 2-3 weeks. We have got a few questions from different students who have been doing the course. In addition, we also would like to clarify some of the concepts which we have taught in this particular 4 modules. All right. So I have with me my 3 TAs, teaching assistants. They're all PhD scholars working in IIT Kanpur. It's Priti, Shomnath, and Suchishmita. And they would be assisting me, and they would give me the questions, and I would try to answer them as best to my abilities. All right. Okay. So, Priti, Shomnath, Suchishmita, would you like to start? What kind of questions have we got?
Sir, I'll start with the first question. So the question is, in city mobility plan, one of the major component has been the freight demand modeling. Is freight demand modeling is similar to passenger travel demand modeling, or do we have some different type of equations or methods to do this kind of demand modeling?
Again, I think this question is not from the first 4 modules. It's a question from a later module where we have detailed out how to do freight mobility plan. We have detailed out the different concepts of freight planning. And yes, freight planning is definitely a part of CMPs or comprehensive mobility plans. And freight planning is a little bit different, of course, as you understand that people and freight, these two are 2 different items, and there are different things to consider. But the main difference between freight and this human or travel demand modeling by people living in the city, the main difference being, whenever we are in case of people, we have certain points of origination of trips, and then there are certain points of destination of trips. And in between, a person himself takes a decision on what is the best way to reach that particular destination from his origin point, and based on the available infrastructure, available modes, he will actually travel along or choose a certain option, right? Or travel along a certain path. But in case of freight planning, there is also point of origin of freight trips. There is also point of destination, when sometimes the destination is not that simple, like a normal trip that we make. For example, a particular company starts from a particular warehouse, but a particular vehicle starts from a particular warehouse, and it goes to multiple shops, right? And then it again comes back to that particular warehouse. So that means here with the trip, we have to go to many shops, and that is where we need to optimize the best way or determine the best way how to reach all these shops using the least possible time or least possible cost and so on. So this is a little bit different from travel demand modeling for human beings. And similarly, the other different major difference that we observe is the people or rather the point of origin or the point of supply or the actual producer of the trip, both in case of freight as well as in case of human travel demand or passenger. In that case, what is happening is, in addition to this, there are again third-party service providers in case of freight, whose job is to provide this service of taking these particular goods from one point to another. So in addition to the producers, in addition to the consumers, there is a third party, which is the logistics provider, which actually manages the trip. So that is something which is different. So these are the different ways we can plan freight and this has to be, and human beings has to be modeled in a different way. These are not the same things. So we will teach you that during the later parts of this course. All right. So what is the next question?
So next question is, in regional plan, are regional boundaries always tied with the administrative boundaries?
It's yes as well as no. It's not a straightforward question. For example, many of the, first of all, when we discuss on or when we do a plan which extends over a large area, which involves many municipal areas, many urban areas, and many rural areas, and so on, and also the connections in between. So obviously, certain things, certain decisions that has to be taken has got, it's not only limited to the boundary of those particular regions, right? So in that case, we need to consider those effects which may originate from surrounding regions as well. For example, the effects are, there could be something like a freight corridor, or there could be a certain production region. So that means maybe whenever we are considering the regional plan, it's better to consider those regions, whichever has got a role to play in those decision making. So if I keep them in the planning, within our plan, that means those new regions would come up. So in that way, the region size will grow. But sometimes maybe one part of the region may play a role, another part may not play a role. So in that case, we will take only a certain part of that particular region, or the region means in this case, a particular administrative boundary. So that means administrative boundaries are very important. Why? Because data availability is based on administrative boundary. Then whenever you are taking a decision on putting a certain infrastructure or taking a certain decision, that is where the regional decision makers come in. Maybe the district administration or the block administration has to be involved in those decisions. So in that case, as soon as there are jurisdictional issues or there are certain things which has to be considered from outside areas, that is the challenge. So that's why even though a regional area is a larger area incorporating various urban bodies or rural areas, it is still better to have formal administrative boundaries encompassing those regions, right? Or other way around. That means we combine a multiple of this administrative regions and then combine it to form a functional region or for this particular transportation plan. So that is the suitable method. But yes, but sometimes there are certain effects from nearby regions, but if I take the entire region, there is no point. So in that case, we can do some violations of this particular rule as well. All right. Okay.
Next question is, how rule-based models are different from cellular automata models?
Cellular automata model are primarily evolved where the concept is whenever we are observing a particular area, and then we divide the area into different parts, and then or different cells and all, means we can use grids or we can use certain shapes and all. Then what we do is we see the change in trend or we observe the trend in land use change, right? And we see how the areas are getting transformed over time. And if this trend holds true, that means this will affect the nearby regions or the nearby cells and so on. So if I apply those certain rules of change to every region, we may see that there is a gradual change in the entire area, and overall it may evolve into a certain pattern. Now, it is this kind of model, as you can understand, is suitable, particularly when we have got less amount of data, right? When we have little data, we can see the changes, certain changes happening, or maybe using some secondary source data like a satellite image and all. And then we want to, draw conclusions, or we come to the point that, okay, if this is the change that we can observe over a certain, over a few decades, then we can see that based on the similar trends, what kind of change will happen, right? But it doesn't have those underlying detailed economic considerations or transportation considerations that we usually do in case of land use transportation models, right? So even though some parameters like accessibility, some closeness to a particular road could be considered, but actually it is not taking into consideration the trips that are generated, or travel demand that is generated out of this particular land use, how it is assigned to the road network, those things are not considered, because that will create those accessibility values, that will create travel time, that will result in certain travel time, which gives a feedback to the choice of people to, to move into this area, or which leads to land use change, right? So these things are not considered. So that's the basic difference. And in rule-based planning, it's again, I will say that rule-based planning is not also 100% land use transportation planning, because what we do here is that is how we usually go about our development plans. Again, when we have got little data or we have little statistical tools, what we do is we have a particular area based on the economic growth of that area and certain other factors. We can predict that what kind of population is expected in that area over the next decade. But as you understand that this is initially we are doing that estimate. And what we do next is, based on certain rules, we allocate this population to the existing developable area, following a certain measure, which actually compares that, okay, like where the suitability is higher for development, or there may be some way of converting it into something like price, like land price and all this, and we can say that, okay, these are the areas where development will happen, and we allocate this extra population into this particular area. But as you know that land use transportation is not that easy, because how an area is evolving depends on so many factors, right? So that means that's why these are both these models are cases where will be used in cases where we don't have that much amount of data, or we want to do a very fast process and approximate estimation, and that is good enough for that particular area, then it's okay. But if you want to go for detailed planning of a urban area, like for example, we want to understand how many people will be using transit during different times of the day, then how many people, like for example, where the new growth areas will happen, like what kind of change in demographic will happen. All the, you cannot measure all these things using this kind of modeling. All right. What's next?
The next question is, why synthetic population is required? What is the difference between population projection and synthetic population?
Well, I think this is a this could be a continuation of my earlier answer. For example, see, whenever we have this a particular area, we can actually project this population based on certain earlier trends, right? Or we can project its population based on more detailed methods where we estimate the in-migration, out-migration, births and death and so on, right? But that actually is a very broad estimate of an urban area, right? But if I really want to get into depth, that means how our urban area is evolving, or what kind of, where people are moving inside that urban area, because there is not only change where people come from outside and come to the urban area, there is also people moving within the urban area. That is, they will shift location from one point to another, right? So that is where we want to have more detailed understanding of the demographic composition of a particular area, so that we can apply more detailed models which take into factor all these demographic and not only demographic, locational demographic characteristics, locational characteristics, and different other criteria. And based on that, people take decisions. They take decisions to move to a new area. They take decisions to go to a particular area. They take decisions on buying a particular vehicle or so on. So all these decisions that are arising out of all your, all these different parameters, that could only be possible if we can use this kind of modeling technique. It is only if we have this kind of data for a particular area. But as you know that there is no such data. That means we don't have any record of detailed data about the people for a particular ward or a particular neighborhood or so on, right? So that means there has to be some other way to determine this, right? So this is where this micro simulation or synthetic population or the overall process is micro simulation, and we first create a synthetic population based on which we will apply these models, and we will micro simulate each of those individuals to determine what kind of overall outcome is coming, right? So that's the micro simulation approach. So that means every individual or every household is important. So now I need to determine this household composition for a particular urban area, but we have no data of it, right? So this is where the synthetic population is created. For example, how we do that? We know that in census, this data sets, we have data on the male, female. That means how many males are there and how many females are there in each ward. We have data on maybe age groups. We can data maybe on certain other characteristics maybe. Now, if I want to combine all this and then create a data set where I can know exactly that, okay, this person in this household probably is of this age or this education level, this kind of, is a male or a female or so on. So if I want to construct that kind of a data set, what we do is we have to do a detailed survey. And once detailed survey means you can do a survey of 1% of the population or 2% of the population, like we do in any transportation survey or in a travel diary, when we develop a travel diary. So once we have done this survey, what we do is there is a certain technique in which we can draw random samples from this particular population and then put it in that particular ward, and then we gradually build up the population of the ward so that the overall consistency of the data, or that means so many males in the ward, so many females in the ward, so many people of different age groups in the ward, this remains consistent. So that is where we need to create this cross tabulation tables. And we have already, I think the methods are already elaborated. You know that we have this iterative proportional fitting method. This is the first part that we do. We create this cross tabulation tables. And once we have that, we have this probability. We know that what share of people is there of a particular type in that particular ward. And then based on that, we can generate this cumulative probability distributions. And then based on certain, this Monte Carlo simulation that we have discussed, we can say that once we draw this person from that survey that we have done, and then we can put it in that group and check if he's matching with the overall structure of that particular area. And we gradually keep on picking these people from that survey data till that particular zone is filled with a synthetic group of people whose overall characteristics match with the data that is there in our, this census tables, right? And that we do based on this cross tabulations, that intermediate steps that we have performed. So once we have created this synthetic population, the next step is to actually, use this data to run the detailed models, or maybe in this case, discrete choice models and so on, where we require all these different, discrete data for each individuals. And once we are able to do that, the results will be much, much more, detailed and much, much more accurate compared to, this aggregate data that we have, where we were using in normal, standard trip generation or trip distribution models, right? So that is the difference why we need to do micro simulation. And I just broadly described you the steps. Of course, you can go through the details given in the lectures, but until unless do this micro simulation, you would not be able to do any kind of discrete choice modeling. And discrete choice models are the, those are, have become very basic, models that has to be applied for determining trip modal choices, then, trip distribution and so on. All right. Okay. So what other questions are there?
The next one is, are advanced survey techniques like app-based, sensor-based, GPS-based, etc., feasible options for data collection in developing countries like India?
Oh, definitely. If all these advanced techniques are coming partially because we are collecting this data. That means if we are collecting data via mobile applications, or we are collecting data via certain sensors, and we are storing this data in databases, large databases, for example, where millions and millions data points are being stored. Like, for example, take the example of buses, right? Buses are fitted with GPS locations. The same with, any kind of, this ride-sharing vehicle like Ola, Uber, they're fitted with this GPS sensors. And this, this GPS models, they constantly send their location, and this location is being stored in the database. Now, how will you utilize this data? That means you have to utilize this data by accessing the database and getting the data. And what is the need for this data? This data will actually give you accurate trajectories of the vehicle along a particular path for maybe those ride-sharing vehicles. And you can do very correct estimates of where the vehicle started, where it went, how many kilometers it traveled, and so on, right? So these are very accurate data. And in case of buses, you can say that, okay, what was the speed of the bus during different times of the day, how long it took. Then using those data, you can do detailed models to do further refined predictions of bus arrival times and so on. So this kind of data is there. And then similarly, I think I've discussed an example in the slide where we have talked about this food delivery. Like, for example, there are so many people working nowadays in companies like Zomato or Swiggy, where all your food is being delivered at your home. And in that particular case, how will you get to understand that how these people operate? Because they get an instruction on the mobile phone, on the app, that this is from where you have to pick up the food and then you have to deliver it somewhere. So until unless you have access to this data, you will never be able to say who is ordering food, or from which points, how many orders are being generated, where these orders are going. So, and then at different times of the day, what kind of demand is generated and so on. So same goes for ride sourcing vehicles. We want to do hotspot analysis, like, for example, at what area of the city, at what point of time, there is a lot of demand, right? So in that particular case, again, also we will need this kind of detailed data to do our analysis to determine where the demand is, right? So this is why we need to have access to this kind of data sets. And sometimes getting access to the data sets is one job. That means we are collecting existing data, but sometimes we can do a surveys using those data sets, for example, or this particular technologies. For example, if I put a mobile app into a particular user's phone, or with his permission, of course, and when he moves throughout the day, we would be able to understand where he has gone. So instead of asking him where he has gone, where he may be wrong, he don't want to be wrong, but he may be wrong because he don't remember exactly the time, and he may fumble with some questions. But if you have this data in front of you, you can tell him, Acha, you went there at 9 o'clock. So what did you do over there? So he may say, yes, I went there for this particular, I went for a shop, I went to a shop. And otherwise he would have forgotten about it, right? So that means this actually is not replacing our service to the fullest extent maybe, but it is making our service much, much more accurate and making the data points much richer so that we can do predictions much more easily. All right. So service could be for buses, service could be for travel diaries, any kind of service could be done in a much more smarter way, utilizing this, this particular tools that we have got nowadays. We can install mobile apps. Actually these are sensors, which are actually people have become sensors, and they are actually carrying the mobile phone, which holds multiple sensors. And if we can get this sensor input and we can utilize the sensor input, automatically you'll be able to analyze a lot of characteristics, a lot of activities of a particular individual. So that is why this kind of smart service are much, much effective. Okay. What's next?
So the next question is for travel demand modeling, peak hour based estimation is better, or the daily demand based models are better?
Well, I think peak hour based prediction is absolutely required because whenever we are doing any kind of travel demand modeling, if I know that this is the peak hour, and if we are able to take care of the peak hour, then probably we are taking care of the major problems, right? But you see, this concept of peak hour modeling is consistent where we want to understand the width or the volume by capacity ratio of our roads. We may want to understand the congestion along our roads and so on, right? But if I want to understand the travel demand by transit, in that case, peak hour has got a certain demand. Using that, if I buy buses, then I will probably buy more buses than that is required, right? Or we may overspend on that. And what would be the effect of that? If I have too many buses, then the fare would be higher, right? Because you are getting you're actually buying more than that is required. Similarly, not only buses, public transit, it's also about like if I understand peak hour, then I don't, and similarly for right sourcing or taxes and all, it's the same concept. Like if I am planning for peak hour, that means when the demand is highest, this the number of taxis that we will give license to would be much higher than that is required in the city. So during other times of the day, there will be these people would be just waiting idling at a particular location. So they will increase both the their income would be reduced. They will result in larger travel distances. They will result in lower more emissions and maybe overall lower profit and so on. So these are some of the issues that is there if you just only plan for this peak hour traffic. And similarly, in today's context also, if you look into the way people travel, people do plan their journeys, right? All throughout the day. It's not like traditional, our offices and all are changing, right? It is not like the traditional office time is morning, everybody starts from their home at 8:30, 9 o'clock, and then reaches office by 10, and then again in the afternoon at 5 o'clock, they all come back. So that is where the concept of peak hour came from. And similarly, in the afternoon, the schools break, and maybe there is a traffic load because of the schools. And then that's why there is a minor peak again in the middle, right, in the afternoon period. So this concept came because of the way people used to work, right? But that's why we need to do a different kind of model in non-weekdays, or we need to estimate for both weekdays and non-weekdays, because in non-weekdays, the travel demand is totally different. But actually, because the way people are changing the way they work, or the companies are also making everything flexible, and you can choose at which slot you can work. So the demand pattern is not that same anymore. So we don't have too much high peaks, and then we don't have, there could be the change in the demand, right? And sometimes the peak is important as well as the non-peak is also important. Why? Because whenever I'm planning for transit and so on, we need to understand what kind of frequency we need to set during peak hour and non-peak hour, so that we can actually plan on, setting up the overall system. Because if too many buses are provided in the peak hour, all of them will go to the other side, and then during non-peak hour, we only bring back a certain amount of buses, which would be much less, to the other side. And so in the next peak hour, there would be no buses to serve that particular terminal. So there are so many issues that results that cannot be solved just by doing peak hour modeling or peak hour planning. And that is where we need to plan for different time periods of the day, at least, not every hour maybe, but at least we have to plan for both peak, non-peak, and semi-peak hours and so on. All right. Okay, what next?
The next question is, what is the role of transportation cost in bid rent theory?
Okay, so that's a basic fundamental question. I think the question of this bid rent, the concept of bid rent basically means the amount of rent a company is willing to pay, and or rather he can bid for, and wherever the asking price for that particular property or that particular place, that by that people who own that, these two matches, that is where this company will be able to afford a place. So how is transportation connected with it? So obviously you can understand, whenever a company, whenever you are located towards the central part of the city, obviously the cost increases, right? Why the cost increases? Because you are in a location which is suitable for, different kinds of function. You are in proximity to other businesses and so on. So that is why, there is centralization of all the different benefits that you can get out of that particular urban structure. So that means that is where, that means your transportation cost probably is also in that case lower, right? So because you can get access to multiple things at one go. But if you are living in certain other place, or you are, moving somewhere else, that means your transportation cost, all these things would be maybe higher compared to other parts through the central part of the city. And that is how, that means because of this accessibility, because of the transportation cost is not only the actual fare you pay for a journey, right? It is the accessibility cost and all the different other costs that comes along with it. And that is, you will see that a place with a higher rent is actually also having lower, maybe you need to spend less value on transportation. So that is how transportation is connected with bid rent. So that means you will willing to pay more money at a location where you can, you have to spend less money on transportation so that you can use that money for, paying the rent, right? So that is how you balance. So that means the amount of money a company can afford is based on the amount of profit it can make. So profit is all cost, the gains that they make minus all cost. So one of the costs is transportation cost. So that is how it is theoretically, you can actually connect this two. All right.
So the next question is, can you please elaborate the basis of selection of cases in fractional factorial design?
Okay, let me remind. Okay. Fractional factorial design is actually, it's a pretty complicated, procedure in itself. But I think you are asking about how do I select the different parameters that we utilize? Is it so?
Sir, I think it's saying like in full factorial design, we have many redundant cases also. So how do we determine which one to select? I think it's
Yes,
like that.
that's what I'm saying. Suppose in a particular survey, there are several, that means when we are doing a particular survey, I think the example that was given in the lecture was something to do with mode choice or some sort of situation where you have to choose, right? That means there are two cases and you have to choose a particular case out of them. And we used several parameters to actually create a certain scenario, and we have to choose which scenario is better, right? And using this choice result, we will actually create a data set, and using on which we would actually run our regression and other sort of models. And we can determine which of the factors are really playing a role in the decision making of an individual, right? Now, the question is, if I consider all sorts of cases and, and possibilities, because, for example, suppose there are 3 parameters and we have got different, cases for each parameter, right? So different, for each parameter there could be 3 values or 4 values. For example, fare could be 5 rupees, 10 rupees, 20 rupees, 30 rupees, and so on. Similarly, there could be another parameter which is time, and that means there is also several values like 10 minutes more than average, same as average, 10 minutes less than average, and so on, right? So in this way, we actually create a combination of different parameters, different options, and give it to the people to respond. Now, if we use all combinations of these options and then create these choice sets and say that, okay, which one you will choose, you will end up with hundreds, and depending on the number of parameters, you will end up with many, many cases. But it is not possible to do so many surveys, right? So that's why we need to reduce the cases. Now, the way we do it is this fractional factorial design. So what we do over here is we consider the orthogonality of that particular, it could, in case of orthogonal, design, there could be other designs as well. We consider the orthogonality of that particular parameter. Now, what it means is, that means how it is connected or related with the other parameters, right? So if a certain combination is not related and we cannot find any sort of connection between that, there is no point of considering that combination. So even though we try to ensure as much variability among the this data point, this options that we are given, like the fare is 5 rupees, 10 rupees, 20 rupees, 30 rupees, and so on. So even though we want to create a different variety, but whenever we are considering combination with other parameters, there would be certain cases where it will not have too much influence or too much connection with that other options. So those are the options that we can reduce, right? And that is where this orthogonal design comes in, which is again based on the existing data that we have got, which the relationships that we don't, which are based on the existing data, we can reduce our design, and so that only a certain cases are considered, and that will reduce the load on our survey. The best possible option is to do all surveys, like all combinations are created and do it. But if I want to achieve the same statistical consistency without doing so much amount of surveys, that is where this orthogonal design comes in. And that is how we decide on a lower size, right? It is more about feasibility of doing the survey. All right. Okay, so what else?
There's another question, like how is the selection of attributes done in a RPSP survey? Can it be used to synthesize a decision framework from mode choice or other related choice decision problems?
Come again. RPSP.
How is the selection of attributes done in RPSP survey?
Okay.
And can it be used to synthesize a decision framework for mode choice or other related choice problems, decision problems?
Yeah. Okay. So see, RP is revealed preference, SP is stated preference, right? Now, RP surveys are basically what? That means there is an existing situation. We survey, like for example, we go to each individual, we ask him what mode he chooses and what is the fare of that mode, what is the time of journey, and so on. And then we come back with that data. Similarly, we survey other people, and then we get a, we create a database, and then we try to develop our models, right? Now, sometimes what happens, because we are using this revealed preference data, that is what is existing, sometimes options or situations which are not existing now, but may existing in future, those are not included, right? So that means we cannot predict that in case the bus frequency is improved by, quite a bit, then we will not be able to understand what would be the result, because those options are not there. Or for example, if metro rail is introduced, what will happen? Because metro rail is not there in your data set, there is no mention of metro rail, right? So you cannot determine if that metro rail is going to have a role or an effect on the decision choice or so on, right? So this is the first point. The second point is the variability of the data. For example, the variability, I was talking about variability a little bit earlier. Now, this variability of the data actually means that, okay, whenever we have got this RP data, usually data is not that varying. That means data means you have got fare of 7 rupees and 10 rupees, maybe nothing more than that, right? So preferably, based on the rules of the discrete choice models, the more variety in the data, even though that data is not there, and if I can give a person about a choice about some other option, even though it is not there, but we can make him compare between two options and we will choose the right option, we can understand that these are the choices he will make or he will not make, right? So that means we can introduce a much more richer variation in the data set by introducing some options which are currently not there, but in future could be there. So that actually helps us to design our models or determine the trend of our models. Or you can say that determine the sensitivity of those models, right? So more varying the data is, it's easier to create the sensitivity of that particular, determine the sensitivity of that particular aspect when we determine a mode choice model or so on, right? So that is why SP experiment is created, where we actually create this choice set that I was talking about earlier, by creating some maybe future parameters or future aspects which are currently not there, or future service levels which are not there, or future mode choice options which are not there, and we can create those options and put them in front of people and say that if this were provided, would you have chosen this? And probably I would have kept it in comparison with the existing situation, right? And people will give us the option. So as you can understand, well, this is hypothetical data, right? And obviously people can say anything. They can say yes to any one of those options. Even though we will ask them to say that, well, you really consider and give a decision, but it's not his actual choice. He is just stating whatever he's feeling about, right? But it is not reflecting his actual behavior. Whereas RP data sets are actually reflecting his actual behavior. So that's why there is a possibility that we can combine this RP and SP data set. Now, how do we combine that? That means there would be some variables which would be there in both. That means whenever we are considering a particular case, in a hypothetical situation, our SP data we have very limited options to introduce the number of parameters. We cannot have 20, 30 parameters. We can have only limited 6 to 7 parameters, right? So we can have limited choice of parameters, and we will include a few hypothetical ones which are not there currently, and some existing parameters which are there currently, right? And in the RP dataset, we can have any number of parameters that we feel that is influencing that particular choice. So in that case, we will have any number of parameters. So when I combine, there will be some overlapping data in between these two, some overlapping parameters, and then there are some parameters specific to RP, specific to SP. And how do I solve this? So when I have these two data sets, this is solved using the scaling parameter. As you know that in nested mode choice models, we use the scaling parameter and we determine the log sum. Here also we do it, solve it in the same way. Only thing is the nesting structure is not considered, right? But the technique, the mathematical or statistical technique is being utilized to solve this. Anyway, I have explained that solving technique later in my lecture, so you can go through that. But conceptually, this is why I would like to clarify that RP-SP data sets are much more richer combined to just SP or just RP data sets. All right. Okay. Any further questions?
No, sir. No, I guess there's not much question.
Okay. Preeti, Shuchishmita, are there any, or we are done?
No, sir. These are the only questions that were there.
Okay. Okay, then. So I think that's all. We haven't got any kind of questions listed in the chat. So we will end our session at this point of time. I think in the subsequent sessions, students who will be watching this lecture eventually of this particular session, you can send us questions. You can send us questions by email or through the forum, and we would be happy to answer all those. So don't feel shy. You can send us any kind of clarifications you require. I understand this is a little bit hard for both architecture and planning students, initially, but you need to push through this initial few chapters so that the subsequent chapters are more very focused on the transportation planning part. And once you do that, you'd be able to do detailed models or detailed transportation plans for an urban area. All right. And any sort of clarifications, if you want, you can just drop me a line and we will be trying to solve it to the best of our abilities. All right. Thank you. Thank you for attending the session. Thank you.
Thank you, sir.